What is ultimate tensile strength in material failure? Imagine pulling on a rubber band or a metal wire until it snaps. What is it that determines how much force it can handle before breaking? That's where ultimate tensile strength comes into play. It is the maximum stress a material can endure when being stretched or pulled before it finally fractures. This point is marked on the stress-strain curve during a tensile test, which is a standard way to measure how materials respond to pulling forces. When a material is subjected to tensile stress, it first stretches elastically. This means it will go back to its original shape once the load is removed. As the load increases, the material reaches its yield strength, where it begins to deform permanently. If you keep increasing the stress, the material reaches its ultimate tensile strength, which is the highest stress it can withstand. After this peak, the material usually undergoes necking, where it becomes thinner locally, leading to eventual breaking. It's important to understand that ultimate tensile strength is different from yield strength. Yield strength is the point where permanent deformation begins. Ultimate tensile strength is the maximum load the material can handle before failure. Brittle materials like glass tend to break suddenly at or near their ultimate tensile strength, with very little warning. Ductile materials like steel show a lot of plastic deformation and necking before they finally break. Measuring this strength involves pulling a standardized specimen in a machine that applies a controlled load. The machine records the stress and strain as the material stretches. The highest point on the stress-strain curve during this test is the ultimate tensile strength. It is usually expressed in units like pounds per square inch or megapascals. Knowing the ultimate tensile strength helps engineers decide if a material can handle the expected loads in a product or structure. It is a key factor in material selection, quality control, and failure analysis. If a material's UTS is too low, it might break under normal use, causing mechanical failure. If it's high enough, the material can be trusted to perform safely under stress. In practical terms, understanding the ultimate tensile strength allows us to predict when a material might fail and prevent accidents. It guides the design of everything from bridges to airplanes, ensuring they can withstand forces they will face during use. So, next time you see a sturdy structure or a reliable product, remember that measuring its ultimate tensile strength was a vital step in making it safe and durable.